Hello, everyone. My name is Tom Schaefer. I've been in the industry since the mid-90s, primarily 20 years as an ultraviolet manufacturer for commercial pools. For those of you who do not know what UV is used for, it goes after combined chlorine or chloramines, which is responsible for the dry skin, the red eye, the odor, the enhanced corrosion inside a facility. So for 20 years, it's been a perfectly acceptable technology. However, for almost 3 years now, I've been promoting advanced oxidation process technology as a superior alternative. Not only does it improve air and water better, but it does so much less expensively. I think after you've seen this presentation, you'll be on board. So advanced oxidation process, wait, I should back up. I do want to remind everyone that at the end of this week is the World Aquatic Health Conference. If you guys want to get clued in with some of the biggest experts in the industry, they will be presenting, as I highly encourage it. I'll also note that the technologies we talk about today are primarily going to be AOP technology and UV. The US EPA is taking a strong stance against any manufacturer that makes claims on their effectiveness against COVID-19. While there have been UV and AOP experiments done in the past on other similar coronaviruses, nothing has been tested against COVID-19 and no claims can be made. This is obviously during a pandemic. A lot of facilities have been shut down. Some have limited capacity, but they're almost all struggling for money. And one thing I would encourage you to look into is the CARES Act. It may be very difficult. The money may have already been allocated, but the technologies we're talking about here today are secondary or supplemental sanitizers, and you can put them on swimming pools. The US Treasury released $150 billion to US states, some big cities, and some counties to distribute that money to help prevent the spread of COVID-19. So you may or you may not be eligible to get that money to put this technology on your pool. But if the money is available and it is allowed by whoever is making the decisions, it'll pay for 100% of the purchase and installation at your facility. There are very few constraints on this money. The technology you're adding could not have been in your budget earlier this year as of March 27th. You need to find out who you need to apply to for this CARES Act money. And then all the money provided by the US Treasury must be spent by December 30th. If not, anything left over will be returned to the Treasury. To give you an example, the state of Pennsylvania received almost $5 billion. You can see some counties on here and the city of Philadelphia. So there may be different entities you may want to look at applying to for this type of money. New Jersey had $3.4 billion. I'm certainly easily available at tom@clearcomfort.com to provide a basic summary of the program as well as the dollar amounts. And we can even provide a sample application to make it super easy. And then lastly, Maryland, $2.3 million. So there was money allocated. I don't know how much is left. So we're going to talk about what is AOP. We're going to look at different types of technologies currently marketed, AOP technologies marketed for aquatics, comparisons to UV, and costs and funding, followed up by Q&A. I do have my chat window open, so if you guys want to interject with a question or a comment, I'll be able to see it, maybe respond to it. So hydroxyl radicals are nothing new, and hydroxyl radicals are what defines advanced oxidation process. And it sounds like crazy science fiction, but it is actually the most prevalent oxidizer in our planet's lower atmosphere. Our planet uses sunlight, ultraviolet light from our sun, as well as moisture in our atmosphere to make hydroxyl radicals. So during the daytime, there's a tremendous amount of hydroxyl radical formation all around us. I came across this study recently, and I definitely need to validate it, but it said within a cubic centimeter of air, which is much smaller than, it's probably at least, what is it, a quarter the size of a cubic inch, there are 2 million hydroxyl radicals, which is crazy. They're all around us, and they actually scrub and clean our air, keep it clean from pollution. They react almost instantaneously. On the oxidation scale, you can see hydroxyl radicals. There are numerous ways to make them in the industry. I'm going to mostly focus on a technology that uses monoatomic oxygen, or O1, similar to how our planet makes them. What the planet does is the ultraviolet light and the moisture in the air break apart, the ultraviolet light and our magnetic planets of our poles break apart O2 oxygen we breathe into O1. That O1 in the presence of hydrogen or moisture is going to produce hydroxyl radicals, which instantly react. As you can see, it's more powerful oxidizer than ozone. A lot of people are familiar with ozone. It's 3 oxygen molecules. One wants to jump off and oxidize something. It's toxic, corrosive, but it's a powerfully great oxidizer and used in aquatics. But what makes hydroxyl radicals or advanced oxidation process better in several ways, but the biggest one I think is the reaction rates. Relative to ozone, hydroxyl radicals react up to 1,000,000 times faster. You're looking at reaction rates of 100,000th of a second or faster. So as soon as they're formed, they oxidize, they disappear, they're gone. You don't have to worry about unhealthy exposure. And again, they're formed all around us in our atmosphere all day long. So the benefit of this technology is very similar to ozone. We're oxidizing out the contaminants in the water, lowering the amount of garbage in the water, and it's breaking them down to elemental phases. It's extremely powerful oxidation. So to summarize how the benefits is by knocking down the contamination level, you're actually reducing the demand for chlorine to oxidize pollution. So your consumption of chemicals is dropped 30 to 50% on commercial pools. And in fact, some facilities have seen 60 and 70% reductions in their use of chlorine. But not only are they reducing their consumption, the chlorine they do use has a stronger oxidation reduction potential. The concentration in the water really isn't a good determination of how well that chlorine works, but the ORP is. And by taking the contamination level down, it's allowing the chlorine to have a stronger capacity to oxidize. So advanced oxidation process has been around realistically since the 1970s. It initially got started for groundwater remediation at Superfund cleanup sites. It was the final step used to break down rocket fuels and pesticides. On all of these subjects we're looking at here, there are dozens upon dozens upon dozens, if not hundreds, of scientific peer-reviewed studies on AOP. It is well known. I noted earlier about how there has been an AOP study done on the SARS virus. The SARS virus is another novel coronavirus that came out of China, but AOP is proven to be a powerful oxidizer and disinfectant, secondary disinfectant. Here are a bunch of studies for all kinds of applications, whether it's industrial, municipal. Municipalities are looking at it for drinking water and wastewater to get rid of pharmaceuticals. Pharmaceuticals, by definition, are very powerful in low concentrations, and they're difficult to get out of our water that we drink. So AOP is proven to be very effective at knocking down pharmaceuticals. Hydroxyl radicals are an indiscriminate oxidizer. They powerfully go after everything. Pertaining specifically to disinfection, there's science going back 25 years on disinfection for bacteria, viruses, protozoan, parasites. So it is a proven secondary oxidizer. So the benefits of using AOP, obviously the big ones for swimming pools are chloramines, which are responsible for the enhanced corrosion, the red eyes, smell. They're regulated by health code. AOP controls them so you have a very fresh environment. You're making that swimming pool experience a non-chemical one. People aren't going to smell the chemicals, feel them, dry their skin out. It has also been proven to be effective on disinfecting crypto. But not only that, it goes after trihalomethanes, which are a chlorine disinfection byproduct class, which are considered carcinogenic. THM levels are typically higher in our pool water relative to drinking water because there are more organics and more chlorine. Haloacetic acids are another chlorine disinfection byproduct class, which are classified as an irritant. AOP is very effective at knocking these down. So there are realistically a dozen to 20 different ways to manufacture hydroxyl radicals. And historically, they've been very complicated, very technical, very expensive. But it's becoming simplified, and they're improving certain ways to do it better. And these are becoming economical for the commercial pool industry. So, and when I say commercial, I deal with commercial, but these technologies are also used on the residential. But the three big ones that are currently marketed are using monoatomic oxygen. The company I work for produces hydroxyl radicals that way. There's also UV and ozone. When you combine them together, the UV breaks down the ozone and makes hydroxyl radicals. And UV and titanium dioxide. So you can have a pipe that is coated with titanium dioxide, and when UV light hits on the surface of it, it produces hydroxyl radicals. NSF 50 is a regulatory, well, I'm not sure they're regulatory, but they're a testing agency that develops standards, ANSI standards for technologies. And they're currently in process on working. They have a task group for AOP, which I'm a member of. I'm a non-voting member. But currently the status of the committee is that they've renamed it an AOP committee. It was formerly UV ozone combo, which really only looked at one type of the technology. Now it's more inclusive for the multiple varieties. They're also in the process of defining what AOP is, and it's proposed that they'll look at some testing to actually prove that technologies that claim to be AOP technologies actually have to prove that they're producing hydroxyl radicals. So when we talk about secondary and supplemental, we're talking about additional ways to disinfect, to treat the water, to make it safer, healthier. And AOP, ozone, and UV are all proven to be good secondary sanitizers. AOP and ozone are oxidizers. They actually burn away, break down the organic material, and it's gone. Whereas with UV, it disinfects by attacking the DNA and RNA and fusing them together. It doesn't kill the pathogen, but it neuters it, so it's harmless. And then it goes after chloramines by breaking down the chemical structure of chloramines. However, there is a little bit of photooxidation occurs, but the majority of the organics remain in the water and can reform back into chloramines later. Some people in the industry may not be familiar with the Model Aquatic Health Code, and again, there's a big World Aquatic Health Conference next week that is associated with the Model Aquatic Health Code to a degree. The Model Aquatic Health Code has a requirement that new pools under construction for high-risk audiences, specifically pools designed for diaper-aged 5 years and younger aged children, as well as therapy pools where there's the potential for likelihood of an open wound, they require that they put secondary disinfection on that pool, again, when it's a new construction. The Model Aquatic Health Code is not law. It is a set of guidance standards the CDC has compiled to try to make sense across the country when city, county, state health officials want to update or revise their aquatic health code. The Model Aquatic Health Code allows for it to become more uniform across the country. These government entities that want to change their code or revise it, they can either choose to select the entire MAC or pieces and parts that they think fit best. The Model Aquatic Health Code is a living document. It's meant to be revised every 3 years. Is it next week? They're voting? Yes. Next week, they'll be voting on changes. And then the next changes to it will happen in 2024. I'm jumping all around on multiple subjects, and I apologize for that, but we're going to pretty much stick with AOP from here on out. So the benefits of AOP are very similar to what ozone and UV do as well. It goes after the chloramines that gives you that chlorine odor, and it's a secondary supplemental sanitizer. There was a comprehensive case study that was done over 3 months where thousands of data points were taken at 2 different YMCAs in Los Angeles County, where they had medium pressure UV on 4 bodies of water and AOP on 3 bodies of water. And AOP just outperformed it. Medium pressure did a good job. AOP did a better job. One of the reasons I think that this is, and this is a theory, by removing the contaminant load or lowering the contaminant load in the water, you're reducing the ability to generate chloramines in the first place. You're also reducing the amount of chemicals you're putting into the pool. So Chloramine control is better with AOP. Now, a lot of people are familiar with Cryptosporidium. It is not a bacteria or a parasite. It is responsible for over 75% of the recreational water park illnesses reported to the CDC over a 10-year period. It comes from the gastrointestinal tracts of infected animals, 140 different varieties, including humans. So if you ingest even a small amount of these parasitic eggs, let me back up. If somebody has diarrhea in your pool, they can release up to 1 million of these little eggs. And a good analogy is they have a leathery, hard outside like a basketball that chlorine has a hard time disinfecting through. So it can take 10 days to even achieve a reasonable level of reduction in viable pathogens with chlorine. So that's why we're looking at AOP, UV, ozone as a secondary supplemental sanitizer, primarily because of Cryptosporidium. Chlorine does a great job on the vast majority of other waterborne pathogens. One of our nation's leading experts when it comes to AOP technology, municipal drinking water, industrial application, wastewater, is Dr. Carl Linden out of the University of Colorado Boulder. He did a study using actual Cryptosporidium and demonstrated that AOP technology is effective at knocking it down. I should back up. And when we talked about the Model Aquatic Health Code requirements earlier for secondary disinfection for high-risk pools, I failed to mention that that standard is based upon the US EPA use of UV technology for municipal drinking water. So the Model Aquatic Health Code does not recognize AOP technology currently as a secondary sanitizer or disinfectant. But eventually, I believe there'll be certifications will allow for more types of technologies. Dr. Linden also did studies on the unhealthy chlorine disinfection byproducts that are carcinogenic and irritants, haloacetic acids, trihalomethanes, and determined that AOP technology is highly effective at knocking down these unhealthy things in our water. Again, we're going to remove that chemical experience by putting AOP technology on a pool by getting rid of the garbage in the water. There was a YMCA in Indiana that had 5 pools, all with medium pressure UV. They didn't like their air quality, so they wanted to look at AOP technology. So they actually hired an independent lab on their own to test for these chlorine disinfection byproducts. And then they put AOP systems on, turned the UV off, and in red is how much better the AOP technology worked at controlling these unhealthy chlorine disinfection byproducts. But what was most telling by the operator is on this very pool that this study was done on, he actually cut his consumption of cal hypochlorine in half and saved $3,400 in the first year. Medium pressure UV is an energy hog. It's very inefficient electrically. You're going to have energy bills in the thousands of dollars annually. What many people don't know is it's very inefficient, and so only 15% of the energy supplied to it is actually emitted into the water in the beneficial range for swimming pools. 85% of it is wasted. So he received, just for switching out the UV system with AOP on this one pool, he received $5,600 in grant money. Ultimately, they replaced all 5 bodies of water. They took the medium pressure out, put in AOP, received $16,000 in grant money, as well as similar annual energy savings. When we talk about chemical reductions with AOP, it's the norm, it's not the exception. You can see it really doesn't matter if it's an indoor pool, outdoor pool, or using liquid, cal hypo, bromine. In fact, we actually see the largest saving on chemicals with bromine pools. But suffice to say, a pool adding AOP will reduce their chemical consumption significantly and save money. This is actually from the West Orange JCC in New Jersey. We didn't ask them to do this, but they compiled data after installing our system and cut their energy or their chemical bill by over $5,000. There are some additional benefits besides, secondary disinfection, reducing chlorine disinfection byproducts. You also improve the clarity of the water. So you can see the difference of what the AOP system did by adding it. And not only is this aesthetically better, And you can imagine the off-gassing of unhealthy chlorine disinfection byproducts gassing off in the pool or vaporizing off. But there is also an important message here when it comes to drowning prevention. The lifeguard's job will be much easier, being able to see into the water much better. The peaks and valleys for chlorine demand can spike dramatically depending upon the bather load. Adding a supplemental technology like AOP will help reduce the severity of those peaks and valleys. And then you can see on the far right, they actually fine-tune their ORP set points on their chemical controller and reduce the severity even more. This is a picture of a large retirement community in Florida. And this is the gunk of an outdoor pool that's all kinds of organics, skin cells, lotions, sunscreens, and it's pretty disgusting. This is what it looked like after adding an AOP system. So we're oxidizing out those skin cells, those lotions. My theory here is, and I don't have a lot of good data yet, is that we're going to increase the time between backwashing your filters. So by doing so, you're going to save on water that you don't have to heat as often or chemically balance as often. So you're going to save on energy and chemicals as well as water. I found this study to be very interesting. I attended the national NSF 50 meeting, was held a couple of weeks ago, and it was almost a joke that people were joking that AOP technology could help on biofilm buildup. But this study from 9 years ago actually noted that by adding AOP technology, you can reduce the amount of chemicals you need to treat biofilm in the plumbing. Many theories. One could be by taking the contamination or the garbage level down in the water, there's less food, and the chemicals you use to go after the biofilms aren't being attracted by the garbage. By getting rid of the garbage in the water, we're reducing the amount of chlorine disinfection byproducts which can off-gas or vaporize off the pool. We actually put a AOP system on a pool. I'm not allowed to say the name of the college, but it is the Big Ten school. I'm allowed to say that. And they put a VOC meter in a room with 4 bodies of water, including this one pool, and it reduced the VOC level by 19%. Air quality is going to be the next big push in our industry, and I truly believe that AOP technology can dramatically improve air quality. Anecdotal evidence from people replacing medium pressure UV have noted that as well. When it comes to installation considerations for all these technologies, by far UV has the biggest physical footprint. You oftentimes, almost always, do 100% bypass. So you have to have 3 additional valves, 2 T's, some 90s, and it takes up a big footprint. And again, you're only using 15% of the energy supplied to it. So you have very powerful fuses and electrical considerations. Ozone is significantly less energy. However, it is complicated. You have a lot of ancillary equipment like ozone detection meters, ozone destruct tanks, air dryers. So there's more pieces and parts to the equation, so there's more opportunity for potential issues. With AOP, it's very low energy, direct injection into the water. We've got some pictures coming up that'll compare. I don't historically deal with residential groups. However, I understand that they may be a part of this organization. So please know that there are residential AOP systems out there. Some are UV ozone, some are monoatomic oxygen, like what you see here. From what I've been hearing, the residential market is booming this year because people can't get out in public. This is what a commercial system would look like. This system could treat up to 700 gallons per minute of water and only require 3 amps of energy plugging into a 110 volt outlet. So it actually pulls air out of the filter room, and it goes through some cartridges in the cabinet that break O2 and the O1, and it injects the O1 into the water. It can be done in 2 ways. On the left, you would cut and tap 2 1-inch NPT holes, screw in a diffuser rod as well as a flow switch, which acts as an interlock. So if flow stops, it turns the system off. As soon as that O1 enters in the water, you're making very powerful hydroxyl radicals, which dissipate within a few feet of pipe. Nothing goes back to the pool as a hydroxyl radical. By far, though, the simplest installation is if you have a surge tank in the filter room, plug it into a 110 outlet, drop a diffuser into the tank, and there you go. A 6 amp system using 310 watts of power can treat a large 50-meter pool up to 2,000 gallons per minute. Medium pressure UV would be so much greater, which is a nice segue into this slide. This is a 50-meter pool in Texas. You can see the UV bypass surrounded in red dots, the 3 additional valves, T's. The power control cabinet that you see in the back with the arrow pointing to it caught on fire, and I used to see this in the past, because those cabinets have to have forced air ventilation to keep them cool. Remember, 85% of the energy is wasted. A lot of that energy is heat. So inside these UV cabinets, they have printed circuit boards which have nano circuitry, and there are tremendous amounts of moist, corrosive, warm air going across them 24/7. Consequently, the inside of these cabinets can become corroded over time, and repairing those circuit boards can be quite expensive. Replacing a cabinet can be the cost of an entire AOP system. So they replaced the UV system with what you see surrounded in the blue dots, very compact. Obviously, if you're renovating and you have an existing medium pressure UV system, you could potentially remove that piping and free up some space. Everyone wants more space in their filter room. Maintenance on AOP systems is extremely basic, at least the monoatomic variety. The UV ozone ones are a little more advanced. You have to drain them, or drain the UV and clean the quart sleeve by hand. It depends how often you have to clean that quart sleeve, depending upon if there's high levels of iron or manganese in the water, as well as lotions, oils. But with a monoatomic oxygen AOP system, you just have to unclip the cartridges, and replace them once every 10,000 hours, which is roughly every 13 months. They're very low energy. The most powerful system has a 60-watt cartridge, much less than an old style light bulb. From an operational cost standpoint, AOP is going to lower your chemical consumption and use 95% less electricity. With UV, you're going to see an increase in your chemical consumption, 10 to 15%, and have a significant electrical bill. So all these, both technologies are good. AOP just does more. It improves air and water in ways UV can't. From an operational expense standpoint, it's vastly superior. I was almost going to talk ahead of myself. Maintenance, obviously, with a medium pressure UV system, they want to drain the UV bypass, pull out the lamp, pull out the quart sleeve, clean the quart sleeve with isopropyl alcohol, replace the wiper O-ring, put it all back together. The quart sleeve and the lamp are very expensive, especially the lamp can be $1,000 for a lamp. And then the quart sleeve has O-ring seals that need compression, that need to be tightened. And if you don't know what you're doing, they can often be broken and they're expensive to replace. You typically hire this out to a third party. With the AOP system, you can easily do that in-house in 10 minutes. We talked early on, and we're winding up, we talked early on about CARES Act money, which I'm learning that although people are using it to add secondary sanitizers, it's becoming more and more scarce to find. However, there are a couple articles that talked about how you can get grant money in 2 different ways. One is simply replacing inefficient medium pressure UV. It's very likely your electrical provider will give you grant money, so you'll see $2,000, $3,000, $4,000 of energy savings by replacing the medium pressure UV, and you may get a similar amount of grant money based upon the annual savings. The second option is something that I think that every facility should look at. Indoor pools, and this is for indoor pools only, not outdoor. Indoor pools bring in more fresh makeup air than they're required to by International Building Code ASHRAE 62. They do this because they have water chemistry issues of chloramines in the pool, and they have bad air, so they bring in more air. If you can do a simple HVAC test to determine the volume of fresh makeup air you're bringing into your facility, and again, this is a simple, inexpensive test, contact your utility providers who heat and cool your air. They may be 2 different companies. Google their name using the terms custom incentive. If they have a custom energy incentive program, you could potentially get significant savings. Case in point, a YMCA in Iowa. It was a small 6-lane pool. They dialed back their fresh makeup air 18%. They received $14,000 in annual energy savings, and then they also received a $17,000 grant. So if you're looking at adding supplemental technologies or changing them, there are additional grant programs out there. So it really doesn't matter if you're using, well, it does matter, but UV, ozone, AOP, they all improve air and water quality. They're all secondary sanitizers, well, disinfectants, sanitizers, and reduce complaints. But nothing is doing it as cost effectively as AOP technology. And the important point here when it comes to public health, if you can dramatically reduce the cost of these secondary supplement or sanitizers, let's say you cut that cost in half, you're not going to double the amount of facilities that can add it. It'll be a multiple or a logarithmic increase. And that greater number is also the greater number of people that have water that has less carcinogens, less trihalomethanes, less chloramines, better pathogen control, secondary disinfection for cryptosporidium. So it's very important for health officials and our market to look at more cost-effective technologies. This is a cost savings analysis that compared a 500 gallon per minute pool, which would be your average 6-lane pool. They looked at the purchase and installation cost, annual maintenance cost, chemical savings, and electrical savings over a 5-year period. And they would save roughly $40,000 in the first 5 years. This is money they can put back into the facility in other ways. Throughout my career, I've often had to follow up with facilities that have had recreational water park illness outbreaks. And one of the great ways to reestablish public trust is to add a supplemental secondary disinfectant system and tell the whole world. And certainly during a time of pandemic, there could be a better time to let people know that we're doing a multiple barrier approach to disinfection. We're not just using chlorine, but we're also using a secondary or supplemental sanitizer. We're just finishing up, and I hope I haven't talked too fast. I tend to sometimes. But I do want to point out that in your neck of the woods, Western PA, Lancaster area, Wallover Architects has jumped on board the AOP train a couple years ago. They're firmly committed in seeing the improvement in air and water quality relative to UV. And so they include AOP technology on their projects. So we're going to see all kinds of improvements. We're going to see reduced chemical use, easy maintenance, improved air and water quality and clarity beyond what UV can do. And it's much more green and sustainable. I'd like to thank you all for attending. If you have any questions in the chat section, I'm happy to answer them. But I'd like to thank the Penn Jersey Association for having me present today. If you want to reach out to me in any way, Tom at Clear Comfort is a great way. Thank you all for attending.
Tom, I'm going to stop you. You do have 2 questions in the Q&A right now.
Okay.
I'm going to take a look there.
Oh, I had the chat open, not the Q&A.
The next one is, in the case of AOP, ozone, UV, how does it impact if a bigger than needed system is installed? i.e., if one was to install the commercial system able to treat 2,000 GPM onto a 30,000 gallon residential pool. And then a follow-up to that is it better, or does it actually destroy or break down the chlorine? Is it wasteful?
Well, if you're talking residential pool, we actually, and I don't work on the residential side, but we have some customers, and we need them to be educated to have a filtration system that runs 24/7. They're knowledgeable about pH and alkalinity. They actually will not use chlorine, but they will use a non-chlorine shock occasionally. But I wouldn't put a 2000 GPM system on a residential pool, but I could do a smaller one. We have systems for 350 and that system you couldn't overdo it because again, these hydroxyl radicals are instantly oxidizing and they're gone. We see chemical savings across the board. We recommend putting the AOP in, the hydroxyl radical formation, before chemical injection, but even on commercial pools where we're put in afterwards, we're still seeing chemical savings. We're not degrading the chlorine to a negative way. I'm not sure I said that very well. When it comes to UV, I am definitely the old school guy. I think I sold the second and third medium pressure UV systems into the US back in 1996. And I promoted it for years. And it's a good technology. It's just not nearly as powerful or efficient. And it's certainly more expensive.
There is a follow-up in the bottom. In this case, it means we ought to just put commercial unit on every pool. Is that correct?
I'm a huge advocate for that. I'm not trying to push the company sales. I'm a big fan of you go to an indoor pool that doesn't have supplemental technology, be it ozone, UV, AOP. It smells really bad. The water has gross chloramines on your skin. It feels dry. Whether it's AOP, UV, ozone, yes, I believe one version should be on every pool. I just think AOP is the best option. Good question on winterization. So with a UV system, you have water in there with essentially a big lamp. If it freezes, you're going to break the lamp. So you have to winterize it. And in the spring, you have to put the components back together. With an AOP system, this is actually a dry system. There's no water running through it. So you don't have to winterize it. The cartridges that are expendable after every 10,000 hours are similar to a UV lamp. As long as you store that lamp properly. If you're a seasonal pool, you're only open for half a year, that cartridge is going to last 2 years instead of 1.